All right, class. Today is going to continue the 3.1, and what we're going to do first is practice two more proofs. These are hopefully ones you've done and gotten on your own. But overall, remember the goal is to make these really, really routine. And so that's why I keep focusing so much on steps you take every time. These are both from page 85, number 2 and number 7. So again, if you haven't tried those on your own yet, you should probably do so before watching this video, unless you're really at sea. So, assuming I copied the problem correctly, I start with my conclusion. Does my conclusion occur in its entirety anywhere in the premises? No. I have a G there, I have a G there, I have a G there, I have an H there, but I don't have any instance of G or not H. Which means, the importance of that question, since I answered no, it has to be a building rule. What's my only rule currently to build disjunctions is addition. If I'm going to get to this with addition, again, side notes are optional, I would need to get G by itself and then add. So what that tells me is that I cannot complete this proof without getting G by itself, so I might as well treat that as my new conclusion. Does G occur anywhere in its entirety, anywhere in the premises? A couple of places. Here is a negation. We don't have rules to break down a negation. But premise 1 is a disjunction, and there is only one rule we have that can break down a disjunction, that is disjunctive syllogism. Can I? Yes. Using which lines? It looks like I can do it with lines 1 and 2, but before I commit that to paper, I'm going to do my double check. Is line 1 of the form P or Q? That is a well-formed statement whose main operator is a disjunct. Yeah, disjunction, yes. Is line 2 of the form not P, where it's a negation of everything before the wedge in line 1? Yes. Notice that those parentheses weren't here. I couldn't do it because then this statement would be a conjunction rather than negation. So I've confirmed I can do a disjunctive syllogism. Next step, I turn my brain off and I write my result, which is simply Q. What's Q? Everything after the wedge. All right. This is numbered, which tells me two things. Thing 1, I learned something new. Go me. But thing 2, I moved what I'm after. I moved my G. Where is my G now? In a conjunction. What is my only rule that lets me break down conjunctions? Simplification. Can I do a simplification here? Well, is this of the form P and Q where the main operator is an ampersand? Yes. Which means I turn my brain off and I complete my simplification. I write P. What's P? Everything before the conjunction. No creativity in logic. All right, why was I trying to get that? Oh yeah, side note, I wanted to do addition. Well, it looks like I'm trying to get to G or not H. It seems like I could do that using line 4 addition, but let's check. Is line 4 a well-formed statement? Yes. Is line 5 a new well-formed disjunction whose first disjunct is identical to everything on line 4? Yes, which means I've completed my proof, proving that G or not H follows from these premises. All right. Number 7 looks like a fun one, and yet I forgot to write the conclusion. I didn't actually forget, I just didn't have room, so I'm going to write it up here. So what you're trying to show follows is G or not S, and it is the case that not E or S. So that's a big, ugly conclusion, and yet how big and ugly it is doesn't really matter because our procedure doesn't change. I ask, does my conclusion occur in its entirety anywhere in a premise? It does not, which means I have to build it, and that's all I need to know, because what type of statement is it? It's a conjunction. What is the only rule that lets me build conjunctions? Why? Conjunction, of course, which tells me I need to get G or not S by itself, not E or S by itself, and can join them. So, might as well treat this as my new conclusion. I cannot solve this proof without getting G or not S. Might as well just treat G or not S as my new conclusion. Does G or not S occur in its entirety anywhere in the premises? Nope, which means I have to build it. So I might do another side note here. What's the only way to build disjunctions with addition? So I need to get G by itself and add. Once more, kind of working backwards, I've learned I cannot complete this proof without getting G by itself, so I might as well treat that as my new conclusion. Does G occur anywhere in its entirety in a premise? Yes, right there, premise 2. What type of statement is premise 2? So since I answered yes, I need a breakdown rule. I need to break down line 2 to get to my G. So, what type of statement is line 2? A conjunction. What's the only rule that lets me break down conjunctions? Simplification. Can I simplify line 2? Well, let's check. Is line 2 with the form P and Q where the main operators and ampersand? Yes. So I turn my brain off and I write P. What's P? Everything before the ampersand, the main operator. I've numbered it, which implies two things. Thing one, I learned something new. That's also important for partial credit if you ever get stuck on these. But more importantly, I moved what I'm after. I moved my G. Where's my G now? In a disjunction. What's the only way to break down a disjunction? Disjunctive syllogism. And here I might take another note. So the importance of realizing that every rule does exactly one thing means that I cannot progress in this proof unless I disjunctive syllogism line 3, period. G's not here. I already broke down premise 2. It has to come out of premise 3, which means I have to do a disjunctive syllogism line 3. I might make a side note of that. Again, you don't get credit for your side notes, but it is there. And so now, what I ask myself, what would it take to disjunctive syllogism line 3? I would need not E. Well, what have I learned? I can't get to my conclusion without G. I can't get G without doing a disjunctive syllogism with line 3. To do a disjunctive syllogism with line 3, I have to have not E, so I might as well treat not E as my conclusion and just do the same as usual. Now, having said that, another bell might be ringing here and say, oh, I haven't done anything with premise 1 yet. But I'm just trying to follow my method here. So might as well treat this as the new conclusion. Does not E occur in its entirety anywhere in a premise? Yep, right there, premise 1. Be more specific. In a conjunction. If I want to get not E, which I have to get G, I have to get not E. What's the only way to break down a conjunction? Simplification, which hopefully by now you realize I can do because the main operator is an and. I simplify not E and not S. I've learned something new and I've moved my not E. It's in another conjunction, and so I just simplify again. And again, you should probably be doing the broken record changes. In line 4, main operator is a conjunction. I turn off my brain, write everything before the and. Now I have not E, and now is the point where the side notes are useful because sometimes these get a little complex. You're like, why was I trying to get not E? Oh yeah, so I can do a disjunctive syllogism with line 3. Let's see. Disjunctive syllogism with lines 3 and 5, but let's go ahead and do a double check on that. Is line 3 of the form P or Q where the main operator is a wedge? Yes. Is line 5 of the form not P where it's a negation of everything before the wedge in line 3? Yes. I've confirmed I can do a disjunctive syllogism. I turn my brain off and I write Q. What's Q? Everything after the wedge. And I'll probably cross this off to remember I already did it. All right. Oh, I was trying to get to G. Where's G? I moved it again. It's in a conjunction, so I simp yet again. If these seem a little repetitive, it's just because we haven't introduced more rules yet. And so that is line 6, simplification. Why did I want that? Oh yeah, I needed to do an addition. To what? Oh, good thing I did my side note. G or not S. Using line 7 addition. Let's double check. Is line 8 of the form P or Q, where the main operator is a disjunction, and the first disjunct is identical to everything on line 7? Yes. So this is a perfectly legal disjunction, and I have half my proof. Now I need not E or S. Does that occur in its entirety anywhere in the premises? That's an and. That's an and. Nope. So I have to build it. Once more, what's my only rule for building wedges? Addition. What would I need to do to add? I would need to get not E by itself. Oh, which I already did. So now I can just do my addition, not E or S. I'll do that's a line 5 addition. I'll just do the same double check. The main operator is a wedge. My P, everything before the wedge, is identical to line 5. Perfectly legal addition, no problem. Why was I trying to get this? Oh yeah, because I need to conclude a conjunction. And so I conjoin premises 8 and 9. G or not S. And not E or S, I should say. Do my double check. So is my product of the form P and Q, where the first conjunct is identical to everything on line 8, the second conjunct is identical to everything on line 9, and the main operator is an and? Yes. Done. So again, the goal is to really, really turn these into a method. And the method won't change. All we're going to do is learn a few more tricks. And so I'm going to talk a little bit about those now. And this is because now we have to talk about some rules of replacement. And what's important to note there is they operate a little differently. And you really want to read the Ulrich Gustafsson carefully, because before we were doing the rules of inference. The rules of inference work like little arguments. They are, as announced, inferences. Rules of replacement are something else. They are replacing all or some part of a line with something that is logically equivalent to it. How? We can determine logical equivalence with truth tables. So we know when two things are logically equivalent. As such, because they're just a different way of expressing the same thing, you can replace a whole line if it's equivalent, or part of a line. And so that's a big difference. So make sure you're recognizing the distinction between a rule of inference, a rule of replacement. You cannot do a rule of inference to part of a line. Those are argument forms. Rule of replacement, you can. So if you look at, say, the inside cover of your book, you'll get rules like commutativity, also known as com. Fun fact, Ulrich actually was the one who invented this symbol, which means is logically equivalent to. So anything in the form P and Q is of the form Q and P. And notice several of these rules have multiple forms with the conjunctions and disjunctions. That's what commutativity says. A lot of what this says is just redundant with what we already talked about. So first of all, notice they are lowercase. So we have to get in the habit of saying anything of the form. This requires a conjunction, not even as the main operator, but as a conjunction. This requires a disjunction. You can com those two. They're commutative. So now, finally, with this rule, we can say if we have A and B, we could finally simp to B. We just have to com first. So I get in the habit of just thinking in terms of simp com simp when I'm breaking down a conjunction, rather than just simp, and I just kind of do it on autopilot. I treat the 3 steps almost as one. But yeah, so we could com this to B and A, and then we could simp to B. If you just try to simp to B, you're skipping steps, not allowed to do that, you will lose points. So, like all the other rules we've learned so far, every rule does exactly one thing. Com is the only rule that changes the order of wedges and ampersands. And again, just remember you could do that for part of a line as well. So for instance, if you had A implies C and not D, you could very easily change that to A implies not B and C. Let me say one other thing about it, just as a part of habit. People make a very common mistake when they're doing a rule of replacement as part of a line. They just kind of forget to write the rest. So instead of writing this, which is the answer, without thinking, they'll just write not B and C with simp. That's going to get you in trouble. And so what I do, say this is line 6. I'll do my usual, line 7, I'll say, write line 6 simp. And then I just carry down everything except, or sorry, com, I should have said. So what I'll do is just carry down everything except what I'm commuting, including the parentheses, so I don't screw anything up. So before I even start to do the com, I carry this all down, and then I ask, is what's left of the form P and Q? Yes, I turn my brain off, I write Q, which was everything after the ampersand before, I write an ampersand, write everything before. So just the carry down method is a good way of foolproofing that. Otherwise, again, everything's the same as the first half of 3.1. But again, com is a unique rule. It has one use, just like all these other ones. It's the only rule that changes the order of wedges and ampersands. Next rule is associativity. P and Q and R is logically equivalent to P and Q and R. Again, you can prove that with the truth table. And again, it's the same for wedges. So, those are equivalent. How do you read this? So when you're checking for your general form, it's a conjunction whose second conjunct is a conjunction. Or in this case, a conjunction whose whose first conjunct is a conjunction, and down here it's same with disjunctions. We didn't need to mention it with com, but it's worth mentioning now. The other way in which things kind of fall out a little different for rules of replacement, in addition to the fact that you could do them to part of a line, you could either go from here to here or here to here. So the order doesn't actually matter. So I could go from here to here or here to here. That's associativity. What is its uniqueness? Associativity is the only rule that lets you move parentheses. It's the only rule that lets you move parentheses. So when you need it, you'll know. The third rule is an interesting one. It's distribution. And if you read it left to right, the name makes sense. However, if you read the rule right to left, it seems more like factoring than distribution. Because if you look, going from here to here, what have I done? I've distributed the P and into the parentheses. It's almost like multiplying. I P in this, and then I P in this. So if I'm going from here to here, I need a conjunction whose second conjunct is a disjunct. If I'm going from here to here, I need a disjunction of two conjunctions, the first conjunct of which is identical. And P or Q and R is the same. I distribute the P or. But again, it makes sense to call it distribution this way, but we really factoring this way. That's a weird-looking rule, and some people just kind of remember it as the rule that deals with all the wedges and it's a really easy rule to screw up. So really focus on what is required for it. So this one is a disjunction whose second disjunct is a conjunction to go to here, or a conjunction of two disjunctions that have identical first disjuncts to go from here to here. But what is it actually doing? And here's what people get too bogged down in the details to remember. What it's actually doing, this changes the operator. This is how I go from an and to an or an or to an and. And so that could be tremendously useful, as we'll see. Another one of those rules that people wanted to just rush ahead and use because we all know it is double negation. P is logically equivalent to not P. You either, depending on which way you go, it's actually more common to go right to left than left to right, but double negation either adds or takes away exactly two negations. And sometimes you'll need that. Think of disjunctive syllogism requires a negation, and sometimes you don't have one. So I gave the example last week. Well, if I have not A or B on a line, and I have A on another line, before I could not perform a disjunctive syllogism, but now all I need to do is double negate A, gives me not A, and now I can do my double negation, my disjunctive syllogism as usual. The last of the rules of replacement for wedges, ampersands, and negation is Demorgans rule. Not P and not Q. This is one we already know. It's not the first and not the second is another way of saying neither. Remember, we talked about this being equivalent to this when we were doing translations. So that's De Morgan. And the other De Morgan, you could say not the first or not the second, is really the same as saying not both. And it's really easy to screw up De Morgan, so I encourage you to kind of keep using your translation skills. Not the first and or not the second. It's very easy to remember turns to not both. Notice the general form of De Morgan's. This requires a conjunction of two negations. This requires a disjunction of two negations. This is a negation of a disjunction. This is a negation of a conjunction. Now, that might seem like an obscure rule, but it's really not, because De Morgan's, let me tell you right now, De Morgan's is the only rule you'll ever have that can get rid of a negation outside of parentheses. And that's huge, and that'll come up a lot. So you want to keep in mind De Morgan's if you have a negation outside of parentheses, and we'll have to learn a few more rules later with some other stuff to do if we can't do a De Morgan's right away. But to rehash, there's 5 rules of replacement. At a meta level, what the important thing to remember is these are logical equivalences. That shakes out in 2 different ways. One, you can do it to a whole line if you would like, but you could also do it to part of a line. So that's thing one. Thing two, the other difference is we could always go from left to right or right to left. So for instance, there's 4 different Demorgans I can do. I could go from here to here, here to here, here to here, or here to here. And so this really opens up a lot of new maneuvers and things we can do. But as always, that we have to be targeted. We have to do some strategy. We can't just start doing stuff because we'll just get bogged down in a bunch of useless details. And so that's why I keep emphasizing each rule does exactly one thing. And it's just about always the only rule that does that. Commutation is the only one that changes the order of wedges and ampersands. Associativity is the only rule that moves parentheses. Distribution is the only rule that changes a dot to a wedge or an ampersand to a wedge or vice versa. Double negation is the only rule that adds or takes away 2 tildes. Demorgans is the only rule that can get rid of or add, I should say, a negation outside of parentheses. By the way, when you're doing Demorgans, it's helpful to count the number of negations to go from here to here. You reduce the number of negations by 1. To go from here to here, you increase the number of negations by 1. So if you need to increase the number of negations by 1, you're not doing double negation, but you might be doing Demorgans. And so I think that's all I'm going to say for now. Otherwise, I'll just turn you loose to practice on the rest of the problems on 3.1, and hope you go from there.